Video 3, number 15, bottom of the first page, b squared plus 6b plus 9. They want us to factor. That's super easy. Parenthesis, 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 b, what times what is 9? That if you add together, 6.
3 plus 3.
3 and 3, positive 3 and positive 3. We are done. So, let's move on to the back side of this page. Number 16. This is an equation. They want us to solve this guy. It is a quadratic. So whenever you have a quadratic equation, you could use the quadratic formula. Or you could try to factor, split, and solve. Either way, you want to get the equation equal to 0. So let's first start out by subtracting 35 and subtracting 35 and rewriting this thing as k squared plus 2k minus 35 equals 0. And now obviously we could identify the a value of 1, the b value of 2, and the c value of negative 35 if we wanted to use the quadratic formula. But before we jump straight into the quadratic formula, let's try. It might work. Who knows? I don't even know. This is the first time I do this problem. It might work where you could factor, split, and solve by having a k here and a k there. Let's think. What times what is negative 35 that if I combine together is 2? Is there a pair of numbers? 5 and 7. Excellent. So we're talking about positive 7 and negative 5. So that's a correct factored form. So it would really be a waste of time to use the quadratic formula here on the final exam. So let's split them and solve. And when we solve it, we're going to get k, subtracting 7 on both sides, k equals negative 7. That's one answer. K, if I add 5 to both sides, k equals positive 5. That's the other answer. There are two answers to number 16. Let's move on. Simplify, assume that no denominator is equal to 0. There's not even fractions here. I don't even know why they would say that. Probably a typo. Right here, you're just multiplying. You're going to be using the rules of exponents. The parentheses aren't even necessary. So we really have a to the fourth, which is really a times a times a times a. And you have a to the fifth, which is really a times a times a times a times a. You get the idea. If you add them together, you're going to get a to the ninth. You have a total of 9 a's. And then the b's, well, how many b's do you have? You have 5 plus 4, that's another 9. So there's your final answer using that rule of exponents, that when you have the same base, you simply add the exponents. Piece of cake? Yes, it is. Number 18. Let's go with the other rule of exponents. When you have parentheses and you have an exponent on the outside, you take this exponent and distribute it to each of the exponents on the inside. And that only happens when you have a monomial. If you had a binomial, like if you had an x plus 2 in here, you could not distribute the exponent. But because it's a monomial, it's all multiplication in here, you can distribute the outside exponent of 3 to the exponent that's on the 7, which is an invisible 1, and you're going to multiply. And then you're going to multiply times the 4, multiply times the 3. So you really end up with 7 to the 3rd, g, that's the ugliest g ever, g to the 12th, h to the 9th. And if that answer is not on your multiple choice, then maybe they wrote it as 7 times 7 times 7, which is on a calculator 343. So you might have a 343 g to the 12th, h to the 9th as your answer. I don't know. We have calculators. You could use the calculators. Let's move on to number 19. Ridiculous. Bunch of letters, exponents. Notice that there is no binomial. It's a monomial. It's a single term. It's a single term. So we could just start multiplying the terms that are alike, and the exponents get added. Before even starting with that, let's go with the coefficients. Negative 2 times 7, that's negative 14. And then, how about the h? You have one h right here, and you have another h squared right there. So h squared times h, that's h to the 3rd, right? So we have negative 14, h to the 3rd. Let's go for the i's now. We have I to the 3rd and another I. That's going to be a I to the 4th power. I to the 4th power. And last but not least, j to the 4th times j to the 3rd. That will be a j to the 7th. ladies and gentlemen, we are done with number 19. Number 20, simplify each expression. On number 20 and 21, it's important to note that we have to treat these radical values like if they were variables themselves. What do I mean by that? Like, let's say I had a 2x, let's pretend this is an x, plus 4y. Would I be able to add 2x plus 4y? No, because x and y are not alike. If it were 2x plus 4x, I could add them together. But right here I have a square root of 45 and the square root of 20. So I need to first start by simplifying these guys and see where that takes us, because we need them to be alike to be able to add them. So I would do some work on the side. So I'm going to do the square root of 45 right here. The square root of 45, not 49, square root of 45, what is that? Give me a perfect square number that you could multiply with another number to give you 45. Anybody? 9 times 5. That's right, 9 times 5. And of course we're going to split the square root, and you're going to get 3 square root of 5 in place of the 45. So I'm going to take this 3 square root of 5 and replace the square root of 45 with it. So I really have 2 times 3 times the square root of 5. So that's really going to be 6 square root of 5. And now let's go to the other one, the square root of 20. That breaks down to 4 times 5, and you could split the root, so you're going to get 2 square root of 5. So when you replace the square root of 20 with 2 square root of 5, so we end up with 4 times 2 square root of 5, which is really going to be 8 square root of 5. So let's go back to here, and let's look at it again as an addition problem, because this addition comes down. So you really have 6 square root of 5 plus 8 square root of 5. And now that you have the same square root values, you could actually add them together and get your final answer, which is going to be 6 plus 8, that's 14. And of course you have that same square root of 5. It's kind of like if it were x's. 6x plus 8x, that's a total of 14 x's. In this case, 6 square root of 5 plus 8 square root of 5, you get that 14 square root of 5 total as a final answer for number 10, or 20. Sorry. So number 21, you're going to do the same thing. You're going to simplify all radicals to be able to see if any of them are alike, and those that are alike you could combine. You cannot say 40 take away 10 is a square root of 30. It doesn't work that way. They have to be like terms. It's kind of like if this were an x, this were a y, this were a z. You can't combine them. So let's start by simplifying the square root of 40. The square root of 40 could break down to 4, that's an ugly 4, 4 times 10, and you could split the square root to the 4 and to the 10, and that'll give you 2 square root of 10. So instead of the square root of 40, we have 2 square root of 10. Let's move on to the next one. Now there is going to be a minus sign between them, but the next one is the square root of 10. You can't break that down. 2 times 5 doesn't help you because neither of those are perfect squares. So we're just going to rewrite the square root of 10 right here. So far we have 2 square root of 10 minus square root of 10. We could actually do that, but we'll do that later. Let's go to the third one over here, 90. Okay, so 90, we're going to rewrite 90 as 9 times 10, and we're going to split the root, so we're going to end up with 3 square root of 10. And that's our third term, and we're going to add that. Okay, so let me go back over here to the other two, and let me put plus the 3 square root of 10 that we have over here. Now that we have all terms that are square root of 10, we have 2 square root of 10, take away 1 square root of 10, plus 3 square root of 10. Now we could actually combine all of them and get a final answer that's going to have a square root of 10. So 2 take away 1 is 1. Plus 3 is 4. And what are we adding here? We're adding square roots of 10. So our final answer is 4 square root of 10. That's our final answer for this one, which I believe is number 21. That's right. Okay, so once again, just to reiterate, you have 2 of this certain type of root minus 1 of these certain types of roots plus 3 of these certain types of roots. So it's kind of like saying 2x minus 1x plus 3x. that would be 4x. But instead of x's, we have square roots of 10. I hope this makes sense.